Hey, I am really glad you made it here with me today. Thanks for being part of this little journey we're about to take. It is always nice to know that out there, someone is ready to travel quietly through space together. I hope you are comfortable. Maybe you are sitting somewhere calm or lying down, or maybe you are just letting your mind wander while you listen. Wherever you are, I appreciate you choosing to spend these next moments here with me. If you like listening to quiet stories about space and stars, please tap the like button. It helps others find this peaceful place too. And if you want to come back for more calm journeys through the universe, please like and subscribe. Enjoy what I do here. And let me know in the comments where you're tuning in from and what time it is for you. It's always fascinating to see who's joining us from around the world. Hey everyone, today we're looking into stars, but not just any stars. We are beginning with a thought that often stirs a quiet curiosity. What would it be like to stand on a neutron star? Drift with me through this stillness as we leave the comfort of our familiar solar neighborhood and move toward a place where matter and energy exist in extremes that the human mind can barely imagine. Imagine a star so small it could fit in a city, yet so dense that a single teaspoon would weigh billions of tons. This is a neutron star, the remnant of a massive star that has collapsed, its matter packed tighter than any ordinary planet or star you know. As you float beside me, notice the faint glow of the star in the distance. Unlike the comforting sunlight, or even the dim warmth of a red dwarf, this glow is strange, almost sharp in its clarity. It pulses faintly, a reminder that inside it, unimaginably compressed energy hums in ways that ordinary eyes cannot see. If you could feel the pull from here, it would be more than gravity. It would be the subtle tug of a mass so dense it warps space and time around itself, bending light, stretching seconds, and compressing distances in ways that challenge every instinct. Picture a star that once burned bright, far larger than our sun, living fast and fierce, pouring out energy until it could no longer hold itself up. When its life reached its end, it collapsed inward, its heart crushed under its own weight until atoms themselves could no longer bear the pressure. Protons and electrons squeezed together, their dance stopped, their spaces erased, leaving behind only neutrons packed tighter than anything you have ever known. Now imagine standing above that heart, a sphere only about the size of a city, yet holding more mass than our entire sun. Reach out with your senses, and you might feel its pull trying to draw every part of you closer, a grip so strong that 1 teaspoon of its material would outweigh mountains back on Earth. The ground here is not solid in any way you understand. It is a crust only a few centimeters thick, beneath which lies a soup of neutrons so dense it defies description. Take a slow breath, even if the air cannot exist here, and think about how strange it would be to plant your foot upon such a place. Your body would be crushed instantly if not for this safe bubble we imagine ourselves within. Yet here we are, hovering just above it, looking down at a surface that spins faster than any wheel you have ever seen. Some neutron stars whirl many times in a single second, their spin a leftover echo of the collapse, a reminder that all that mass has nowhere else to go but around and around. If you close your eyes for a moment, you might hear the faint whisper of its magnetic field, so strong it would tear electrons from atoms in the air if there were any. It hums like a distant, low chorus, filling the void with an unseen vibration. Look to the horizon, if you can call it that, and you will see how space itself seems to bend. Light does not travel straight here. It curves, falling toward the star, making the far side appear as though it wraps up and over, showing you what should be hidden behind. This bending lets you see nearly all of the star at once, like a marble with its skin stretched toward you. Now reach out your hand again. Do you feel that? Not the heat of a flame, but the pressure of sheer gravity pulling at your fingertips. If you were to drop even a tiny pebble, it would strike the surface with unimaginable force, releasing more energy than the largest explosions you know on Earth. Time here, too, plays tricks. If you stayed too close for too long, you would find that moments pass more slowly for you than for those far away, as the star's gravity pulls at the very fabric of time. Think about what it took for this star to become what it is. Once, it had light and warmth, and maybe planets circling its glow. Now it is a silent monument, a remnant of a great life gone still, spinning in the dark, holding the memory of a sun in the tightest embrace nature can make. Around it, perhaps, drift the shattered remains of its former worlds, thin rings of debris or faint gas clouds that whisper the story of its fall. You and I, standing here, are visitors at a place where matter has been pushed to its final limits without becoming a black hole. It is a threshold, a point where you can almost taste the edge of what space allows before it disappears into something even stranger. And yet, despite its ferocity, it is beautiful. Its surface gleams with a faint, ghostly light, sometimes pulsing as its beams sweep across the galaxy, like a cosmic lighthouse that turns its silent gaze outward every second or two. Let us pause here together, floating in this quiet pocket of space, where the stars are distant pinpricks, and the void feels wide enough to hold every thought you have ever had. Ahead of us, a strange world waits, one so dense and heavy that even your imagination hesitates before stepping closer. How strong would gravity feel if every step pressed you down like an entire mountain on your shoulders? Take a slow, steady breath as we draw nearer, because the closer we come, the more the idea of weight begins to change. Picture standing at the edge of that immense pull, a place where the fabric of space itself seems to lean inward. The moment you try to move your foot, the force beneath you would not feel like the soft, familiar tug of Earth. It would feel as if 1,000 invisible hands were pushing down, each one heavier than the last, until your knees would want to buckle and your chest would tighten under the invisible pressure. Even the lightest step would demand the strength of giants, and yet the star we approach, this neutron star, is no larger than a city. It is a paradox wrapped in a sphere of unimaginable density, and here we are, daring to hover just above it. Close your eyes for a heartbeat, and think about the mountain ranges on Earth, the towering peaks of the Himalayas, the ancient shoulders of the Andes, the snowy spines of the Alps. Each one is heavy beyond easy reckoning, but here a single spoonful of this star's matter would outweigh all those ranges combined. Now imagine that same mass pulling on your body with every tiny movement. If you reached out a hand, the very act would feel like lifting a mountain's worth of stone. Your breath would come slowly, your muscles would ache with each thought of movement, and time itself would seem to stretch, because even the smallest action takes so much effort under such gravity. Look around with me and see how space behaves here. The horizon is bent into a curve that never quite lets you look away from the star's surface. Light, usually so quick and careless, drapes itself along these invisible lines, bowing under the weight. If you dropped something, even something as small as a grain of sand, it would fall not with a gentle drift, but with a rush so fast that in an instant it would release a burst of energy rivaling the mightiest explosions back on Earth. You might wonder what it would feel like to try to walk here, to take a single step. Even with the strongest suit, the most reinforced shell of protection, your feet would hardly leave the ground. The gravity would clamp you down, an unending reminder that you are a guest on a star that has been crushed to the edge of possibility. A single stumble would not end in a fall, but in a forceful, unstoppable pull that no strength could resist. And yet, within that ferocity lies a quiet kind of beauty. The surface may seem plain dark, cracked, perhaps with faint glimmers of light, but its very existence is a monument to the end of a sun's life, a testament to the immense energy once poured into its heart. Each pulse of light it sends, each faint beam sweeping the darkness, carries the memory of the star it used to be, a message still traveling through the cosmos. If you were to stay here long enough, you would notice how time bends for you. Seconds stretch a little longer, your clock lags behind the clocks of those far away, and every heartbeat feels like a small anchor in the flow of the universe. It is not just the weight of your body that is changed, but the weight of time itself. Now let your thoughts drift outward again. Beyond this crushing gravity, beyond this tight sphere, lies a galaxy still turning, stars still being born, planets still circling their suns. Yet here, standing at the edge of this neutron star, you are touching one of the most extreme places a traveler can reach without slipping into the unknown of a black hole. It is a place where the word weight is no longer just a number, but an experience that reshapes how you think about every step you have ever taken. Let us drift even closer now, as if the dark ocean of space itself is guiding us to the very edge of this strange and powerful world. You feel the air around you, or what little there is out here, grow still and heavy as we near the surface of the neutron star. What would happen to your body if you tried to lift even a finger there? Think about how effortless it feels to move your hand right now, to stretch your fingers wide, to close them again without a second thought. Here, that simple act would become something else entirely, something almost impossible. The gravity pulling at you is so intense that every muscle in your arm would tremble under its grasp. Your bones, which have carried you your whole life, would creak like ancient trees in a storm. The joints that usually bend with ease would lock, not because they refuse to move, but because the force pressing them together is greater than anything you have ever known. Lifting a single finger would feel like trying to raise an entire mountain range from the ground. The strain would surge through your hand, up your wrist, into your shoulder, until the very thought of motion feels heavy. Imagine that each finger holds the weight of a great ship resting upon it. You would try to wiggle one, and instead of a light twitch, you would feel a deep ache spread through your nerves, telling you that the world beneath you is not built for softness or comfort. Even the smallest gesture, the kind you would normally make without thinking, would demand a force that your muscles were never meant to deliver. Your blood would feel different too. Each beat of your heart would struggle to push it along, as if every drop had turned thick. Your lungs, trying to rise and fall, would fight against the invisible pressure pressing on your chest. A breath, something so simple where you came from, would turn into a careful task, each inhale a victory against the weight that holds you down. And yet, here you are, standing on the edge of one of the most extreme places the universe allows. The surface beneath you might appear calm, a dark and solid plane with faint glimmers of trapped light in the cracks, but it is the densest matter you could ever hope to meet without vanishing entirely into the unknown. Every atom here is crushed together, packed so tightly that the space you once thought existed between particles is gone. Think of the Earth, the place you know so well. There, gravity feels like a companion, gentle and steady, a force that lets you walk, run, dance, and reach for the sky. Here, that same idea has grown into something fierce and unyielding. To lift a finger is to challenge the very heart of this collapsed star, to ask it for permission to move, and the answer it gives is always a crushing pull back toward the surface. Look up with me for a moment. The stars above still shine, though their light bends as it passes close to this world, curving gently as if bowing to its strength. Even light feels the weight here. Even the swiftest thing we know cannot escape unbent. And you, standing so small upon it, are part of this strange ballet of pressure and force. If you could stay here safely, you might begin to learn its rhythm, to breathe slowly, to rest your hand upon its surface without trying to fight. But the truth is that this place does not want to be held or tamed. It is a relic of a great star's final breath, a core left behind after a titanic collapse, a monument to density itself. Take a slow step with me closer to the surface of this neutron star. The space around you feels almost still, yet you can sense an invisible weight pressing against every part of you. Now think carefully about something you have done thousands upon thousands of times without even noticing. Breathing. Could a single breath be enough to crush your lungs under the immense weight? Out here, that question is not just a thought. It is a reality waiting at the edge of each inhale. Picture the gentle rise and fall of your chest on Earth, the easy rhythm that carries air in and out without struggle. Here, that same motion turns into a battle. As you draw in a breath, the gravity of this place presses down on your chest with unimaginable force, as if the air you pull in suddenly becomes thick as stone. Your ribs strain, your muscles tense, and the soft tissues that usually stretch with ease feel locked in place. One inhale feels like lifting a mountain, one exhale like pushing that same mountain away, only to feel it roll back over you again. Every part of the act becomes deliberate. You cannot simply fill your lungs. The air would feel as though it has turned heavy, not because it truly has weight in the same way a rock does, but because the force pressing inward from all directions leaves no room for it to expand freely. Each breath would need effort greater than running your fastest race back home. You might manage one or two, but each one would leave your chest aching, your heartbeat racing, your mind whispering that you are trying to breathe in a world that does not want you to. Even the delicate pathways inside your lungs would protest. The tiny branches where air spreads would be squeezed, not shattered outright, but forced so tight that oxygen would struggle to move. It would be like trying to sip through a straw pressed shut by a giant hand. Your diaphragm, the muscle that does most of the work when you breathe, would feel like it is being pushed back into your spine, trapped between the will to live and the pull of a collapsed star. And yet, if you could pause in that moment, if you could freeze it, you would see something almost beautiful. The surface beneath you, dark and solid, carries the memory of a star that once shone across the cosmos. The gravity that makes breathing so hard is the same force that kept countless planets in place long ago, the same force that gathered the first clouds of gas into the star that died to make this. Take another breath with me, even if only in your mind. Feel how shallow it would have to be. A careful sip rather than a full lungful. Feel how your ribs would resist, how the weight of this place does not want you to rise, only to sink closer to its heart. Each breath is a victory, small but fierce, in a place where even light bends and struggles to escape. Stand with me here on the edge of this dense world, and let your eyes wander outward. You might expect a horizon like the one you know from standing on a hilltop or gazing across the sea back home. A gentle line where sky meets land or water, something distant yet familiar. But here, under the immense pull of a neutron star, the horizon does not behave like a simple line. What would it look like if light itself bent around the curvature of the star? Let us trace it together. First, notice how the surface curves sharply beneath your feet. A neutron star is only about the size of a city, maybe 20 kilometers across, yet it holds more mass than our entire sun. Its curve is tight, steep, a ball of staggering weight packed into a small space. On Earth, the horizon feels far away because the planet is large, and your eyes see only a small part of its sweep. Here, you might expect to see the edge just a short distance away, and yet, as you look, something strange begins to happen. Light refuses to travel in straight lines here. The pull of gravity is so strong that it bends the very path of the photons leaving the surface. Rays that should have streamed away into space are dragged back, curved like ribbons caught in a whirlpool. You see places that are not truly in front of you. The far side of the star leaks its image over the top, bending the view so that the horizon does not hide what is behind it. It is as though the surface curls up to meet your gaze, wrapping around you, making this tiny world feel at once too small and strangely endless. If you stood still and turned slowly, the bending light would paint a distorted panorama. Objects that should sit behind the star would peek over its edge. The horizon would no longer be a simple circle. It would be a continuous, warped band, where everything folds in toward you. Look down near your boots, then trace your view outward. You might find yourself seeing more than half of the sphere at once, almost as though you have been lifted above it, even though your feet remain planted on its crust. This bending is called gravitational lensing, but names matter little when you are here to witness it with your own eyes. It feels less like a trick and more like the star itself is pulling your sight into its embrace, refusing to let even light escape its reach without a final twist. The horizon seems closer, yet it holds far more than it should. Imagine a beam of starlight from a nearby sun passing close to this neutron star. It would not move in a straight line past your view. It would curl, bend inward, sometimes even swing completely around before continuing. This bending creates mirages, places where light piles up, making some regions shimmer more brightly than others. You might see a faint halo encircling the star, a ghostly ring where light from the background has been forced to bow. Step with me a little nearer to that horizon. You would feel the same crushing weight in your legs that we spoke of before, but now your eyes would try to piece together a world that refuses to behave. The horizon no longer marks an end. It is more like a window folded back upon itself, a reminder that gravity here does not only press down, it warps the very stage upon which light dances. If you stretched out your arm, the shadow it cast might curve oddly along the ground, bending in ways your mind struggles to predict. Faraway stars would smear into arcs. The very idea of up and down starts to lose its grip, not because you have lost balance, but because the fabric of space near this star does not care for straight lines or flat views. Take a moment now and breathe as calmly as you can in this thought. The horizon is no longer a simple border. It is a bending, twisting frame that lets you see what should remain hidden. In that warped glow, you can almost feel the star whispering its power, not in sound, but in the way it pulls even the fastest thing in the universe, light itself, into its grasp. Lift your eyes upward now, and let them drink in the sky that hangs over this strange and heavy world. You might expect darkness speckled with stars, much like a winter night back on Earth. But here the view is shaped by something far more forceful than a simple blanket of space. How would the sky change when magnetic fields are 1,000,000,000 times stronger than Earth's twist light around you? Let us explore that together, slowly, step by step, as if we were painting the scene with our breath. First, try to picture what 1,000,000,000 times stronger really means. The magnetic field of our home planet gently guides compass needles and helps protect us from the sun's charged winds. It is strong enough to shape beautiful auroras at the poles, curtains of green and red that ripple like silk. Now take that quiet strength and multiply it by 1,000,000,000. It is no longer a gentle guide. It becomes a colossal, invisible hand, one that grips particles, stretches them, and bends their paths as easily as a stream bends twigs. On a neutron star, this magnetic field can twist the very space around it, turning the sky into a restless canvas. Look upward again. Starlight passing near this star does not move cleanly. It twists, it stretches, it curves in ways that would make an artist's brush tremble. You might see streaks where there should be pinpoints, faint lines drawn by the dragging of photons caught in the field. Some colors could split apart, scattered differently depending on their energy, so that a single star in the distance wears a strange halo, red and blue smeared like oil on water. If you turn your head, you may notice beams of light forming, not from lamps or torches, but from the star itself. These magnetic fields often funnel charged particles into narrow streams, creating blazing lighthouses that sweep across the sky. They are called pulsar beams when they spin and flash, but here you are standing beneath the very forge of such light. Imagine a stripe of pure energy racing over your head every second, like the wink of a cosmic eye. Your own shadow would refuse to behave. It might twist, shrink, or stretch as these invisible threads play with the light. If you raised your hand, you might see faint glows trace along your fingers, as if the field is whispering to the atoms in your skin. It would not burn like a flame, but it would hum in its own quiet way, a reminder that the rules you knew have been rewritten here. The sky would not hold still either. The field can trap particles and make them spiral along its lines, and when those particles meet the thin layer of matter still clinging to the star's surface, they can spark radiant flares. Imagine sudden ribbons of brightness arcing across the heavens, not soft like Earth's auroras, but sharp, quick, and intensely bright. They could flash in violet, green, even ghostly white, dancing for heartbeats and then vanishing. And because the magnetic grip is so strong, it even affects the very vacuum around you. Empty space is not truly empty here. The field can polarize it, turning it into something that bends light differently depending on the direction it travels. This means the sky could shimmer like a soap bubble turned on its side, edges of stars wavering, dim regions flickering as if the universe itself were breathing. If you gazed long enough, you might start to see shapes where none exist, your eyes struggling to untangle the bent light. The constellations you once traced back home would not match here. A familiar cluster might stretch into a crooked arc, while distant galaxies seem to double, their light paths split by the field's invisible grip. Close your eyes for a moment and feel that presence. It does not roar, it does not crackle like a storm on Earth. It is steady, immense, and ancient, threading through every inch of space around you. The magnetic field of this neutron star is not just strong, it is a sculptor, carving the light itself, shaping the sky into something living, restless, and slightly unnerving. When you open your eyes again, the sky is no longer a backdrop. It is a river of bent starlight, a shifting map that refuses to stay still. Every blink shows you something slightly different. Every turn of your head reveals a new distortion. And through it all, that mighty field hums silently, 1,000,000,000 times stronger than the one that swirls over our oceans and mountains, reminding you that here, even the emptiness is charged with power. Let us step closer now, close enough that the very surface of this neutron star fills our view like a restless sea frozen in place. You can almost feel the tension in the space around it, as though the air itself is holding its breath. What colors might shimmer across the surface in a magnetic storm unlike anything on Earth? That is not just a question of imagination. It is a window into a world where the rules of light and matter bend in ways our home planet never shows us. On Earth, a magnetic storm can paint the sky with curtains of green, hints of purple, streaks of red. These come from gentle streams of particles funneled by our planet's field into the upper air, where they dance for a while and then fade. Here, those same forces are not gentle. The field is a trillion times stronger, fierce enough to wrench electrons and protons into spirals so tight they scream across the surface like threads of lightning. Each burst they create can blaze brighter than the sun for a heartbeat, then vanish into a cold hush again. Imagine standing on a rise of this star and seeing a sudden arc of violet whip across the dark crust, so bright it cuts a scar of color into the night. Not soft lavender like a spring flower, but a deep violet that seems to glow from the void itself. Just beyond it, a flare of blue erupts, electric and sharp, turning shadows into quicksilver outlines. You might see green as well, but not the soft northern lights of home. Here it would flash like a blade, vivid and fierce, tracing the lines where particles slam into the surface. Reds could appear too, not as gentle fading embers but as molten streaks, each one marking a sudden release of energy. Where the crust bends under the strain, they would ripple and vanish, leaving faint after-images in your eyes. Some bursts might even reach into the ultraviolet, a color you cannot truly see but can feel as a prickle on your skin, as though the light itself is whispering warnings. The surface would not glow evenly. It would shimmer in patches, each storm feeding the next, each arc of light twisting into the one before it. If you stood there, your shadow would flicker wildly, stretching, breaking apart, then snapping back with each pulse. The ground might appear black one moment and gleaming silver the next, polished by the flood of charged particles striking it. Close your eyes for a moment and think about what that means for time itself here. A storm could rise and fade in less than a blink, yet its mark might linger for hours, slowly cooling in colors we barely have names for. The crust of this star is so dense that even a thin flash carries the energy of a billion thunders, yet from a distance, it is just a shimmer, a quick ripple in the dark. If you open your eyes again, try to follow one of those lights as it crawls across the horizon. It does not move like a cloud or a wave. It jerks and snakes, its path tied to the tangled lines of the magnetic field beneath. Each twist tells you where the hidden strength of the star lies, like a map written in fire and frost. The colors here are not just decoration. They are the voice of a dying star speaking in light, telling you where it still fights to hold itself together. And as you stand there, the storm might quiet for a moment, the glow fading to faint violet smears and thin green threads, before another wave of energy surges up to take its place. Take a slow step closer in your mind, not because it is safe to do so, but because this is the only way we can truly imagine it, without being crushed in an instant. The surface of a neutron star spreads before you, neither like the ground beneath your feet on Earth, nor like the bubbling seas of lava you might picture on a young planet. Would the star feel solid, molten, or something that defies every sense you know? That is the riddle waiting here, and the answer is not what instinct would whisper to you. At first glance, it might seem solid. There is a kind of crust, a thin layer, where atomic remnants cling together under staggering pressure. It might even hold your weight, if your weight were not multiplied to something far beyond what any bone or metal could carry. But that crust is only a skin, a few meters thick at most in some places, and beneath it lies something that refuses to fit into the simple labels we use for rock or metal or molten core. Imagine running your hand across it. If somehow your arm could survive such a place, it would not crumble like soil or dust away like sand. It would resist, hard and unyielding, the way a diamond might feel if the diamond were crushed under the mass of a mountain. The atoms there are packed so tightly they barely remember they were once separate things. The space between them has almost vanished, squeezed away until matter itself has changed. Yet this is not a solid in the sense of a mountain or a metal slab. Beneath that crust, matter flows, but not like water or lava. It does not ripple with the smooth heat of molten rock. Instead, It moves as a kind of sea made of neutrons, a superfluid that carries no friction, that slides with no resistance, that lets energy and particles slip through as though the rules of nature forgot their usual grip. Picture an ocean where each drop is a crushed ghost of an atom, stripped of its charge, packed together so tightly that a teaspoon would outweigh a mountain back home. If you could press your fingers against it, you might feel both hardness and a strange yielding, as if the crust remembers it is holding back something restless, something that wants to sink and spread and flow. The heat beneath would be immense, yet because of the density, it would not blaze like an open flame. It would smolder, trapped beneath the surface, leaking out in bursts that carry more energy than a billion thunderstorms combined. The star would not feel warm the way a campfire does, where heat washes over your skin with gentle waves. Here, heat is trapped, and the thin crust locks it in until it erupts. So to your senses, if you were somehow protected from the gravity, the radiation, and the tearing fields, it might even feel deceptively cold at times, with only rare storms breaking the stillness and reminding you how alive it is inside. And then there is the way this strange matter responds to touch. It would not crack easily. It would not dent without a force so vast you cannot summon it in your mind. But once breached, it can quake, sending ripples across the surface that race faster than sound. Each tremor could twist the magnetic fields, send flares into space, or even change how the star spins. So what would it feel like? Not solid like rock, not molten like magma, but a paradox of both. A crust hard as diamond, a sea beneath smoother than any liquid you have known, all held together by gravity so fierce it bends the space you stand in. It is a feeling your senses are not built to measure. It would confuse your balance, numb your sense of touch, and leave you unsure if you stand on something firm or float upon a restless ocean frozen in place by its own incredible weight. Take a moment to stand very still in this strange place, letting your mind wander across the hard yet restless skin of the neutron star. Could sound even exist, or would vibrations be silenced under such extreme pressure? It is a question that peels away the edges of our familiar world, because here, the rules that let your voice travel through the air and your ears catch a whisper are torn apart by forces too immense to fit in everyday thinking. On Earth, sound is a ripple, a chain of little pushes through air, water, or solid ground. Each molecule bumps the next, and your ear gathers those bumps as waves. Here, there is no gentle cushion of air, no soft blanket of gas to carry a song. The space above the crust is almost empty, a vacuum so deep that even light has to fight to escape. If you opened your mouth, no breath would come, and no shout would stretch across the dark. It would vanish before it began. But press your feet to the surface and think deeper, because sound does not need air if it has something else to move through. The crust of this star is dense beyond imagining. Atoms crush so close together that they barely know where one ends and another begins. In such a place, a tap of your foot could send a vibration racing along that rigid lattice faster than anything you have ever heard before. These are not the gentle tremors of stone or steel. These are quakes that can span an entire star in a heartbeat. Yet what would your ears catch here? They are built for soft waves in thin air, not the deep, heavy shudders of neutron-rich matter. The pressure is so enormous that even the idea of a vibration becomes something else. The crust might carry a note, but it would be a note too high or too strange, too tight-packed, for the human ear to truly follow. It would sing in pulses of energy rather than the familiar rise and fall of sound we know. Imagine crouching low, placing your hand on the surface. Feel the faint trembling as magnetic storms twist and release their power. These are not sounds you could hum along with. They are more like the heartbeat of a giant, felt in your bones rather than heard in your ears. The pressure here would crush your eardrums long before they could listen. But if somehow you were wrapped in a perfect shell that let you survive, you might feel every starquake as a deep thrumming in your chest. Silence, then, is not quite the right word. It is not the empty hush of a quiet room or a snow-covered forest. It is a silence filled with invisible motion, a pressure so immense it smothers the usual ways sound is born. Each tiny tremor holds the weight of 1,000 mountains shifting at once. Each ripple in the crust could carry more energy than the strongest earthquake ever recorded back home. And still, the outer vacuum offers nothing to carry a melody. So, If you and I stood side by side and I tried to whisper a story to you, my lips would move and no word would reach you. Only the touch through the star's skin, only the feel of it, would tell you that the world here is far from still. The quiet is not emptiness. It is the quiet of too much matter pressing together. The quiet of a drum stretched so tight it does not rattle. It only hums with hidden force. Let us pause here and settle into the strange rhythm of this neutron star, letting its weight press against your senses as we consider something that feels impossible in our daily lives. How would time feel when gravity stretches it, slowing every second for you compared to distant observers? Out here, near the surface of this star, time does not march steadily. It bends, stretches, and lingers, as if the universe itself has paused to watch the smallest heartbeat. Picture yourself standing on the crust, the dense, hard skin beneath your feet pressing down like 1,000 mountains. Yet somehow you are alive. Somehow you can observe. Around you, space continues its usual dance. Stars spinning, light traveling across vast distances. Yet your own experience of those moments is slower. A second for you might feel like 2, 3, or even more for someone far away in the emptiness beyond the star's grip. Every pulse of your heart lingers. Every blink of an eye stretches into a quiet eternity. You might lift your hand slowly, marveling at how even this tiny gesture seems to take its time. The motion is no faster than it should be, yet in comparison to the rest of the universe, you are moving in slow motion, a visitor out of sync with distant galaxies. The stars above, normally twinkling and shifting with ease, seem to blur as if their light itself cannot keep pace with your slowed perception. You could watch a distant star flare and fade while you measure each moment, each change stretched into a gentle unfolding. Even breathing becomes a study of time here. The pull of gravity slows the rhythm, every inhale and exhale drawn out. Your chest rises and falls in deliberate arcs, as if the star itself is guiding the tempo of your life. A heartbeat feels expansive, like the echo of a drum resonating in a cathedral, each thump reverberating longer than it would anywhere else. Imagine a pulse of light from a faraway pulsar. To observers at a distance, the pulse flashes quickly, steady, and precise. To you, standing near the neutron star, it appears slower, almost languid, as if the universe has given you a rare moment to savor the pattern. You feel the weight of that time stretching in your mind, pressing gently yet insistently, reminding you that gravity is not just a force of pull but a sculptor of experience. Step back mentally and consider what that means for life beyond this star. Planets orbiting distant suns continue their orbits. Creatures far away live their lives. Seasons pass, and yet here you stand, almost suspended, each second a quiet eternity. You might watch billions of stars move in what feels like a slow dance, tracing their paths across the sky, while for someone light years away, that dance is completed in a blink. This stretching of time is not uniform. It is strongest at the surface, where gravity presses most fiercely. Move a few kilometers upward, and seconds return closer to their usual pace, the difference subtle but real. Here, standing on the neutron star, you are caught in a pocket where moments are thick, rich, and heavy, every tick of a clock magnified, every blink a meditation. Think about how your perception would change. Tasks that normally feel quick, like lifting your hand or turning your gaze, become long, deliberate, almost ceremonial. Movements that once seemed casual now feel like they must be chosen with care, because each second carries more weight than your mind is used to carrying. Time is no longer a background measure. It becomes tactile, something you feel in the rhythm of your own pulse. Step closer with me now, right to the very edge of the neutron star, where the solid crust begins to give way to the almost non-existent atmosphere above it. This is a place unlike any you have known. The surface beneath you is firm and dense, yet the world above it is nearly empty, a thin whisper of particles struggling to exist. What would the edge of the star feel like, where the atmosphere merges into almost nothing? Let us linger there and feel it together. Beneath your feet, the crust carries weight beyond imagining. Atoms crushed into a lattice so tight that a single teaspoon would outweigh a mountain. Yet just above this, there is almost no air to speak of. The transition is not gentle. If your senses could detect it, It would be as though you were walking from a room filled with a heavy fog into a vacuum, so complete that even the faintest pressure seems absent. Your skin would feel the shift, a sudden release from the crushing touch of matter beneath into a near-total emptiness above. As you extend a hand, you might imagine brushing through the star's faint atmosphere. It would offer almost no resistance, almost no feeling of particles, yet you know that each particle still holds energy, moving at incredible speeds, responding to the star's magnetic and gravitational grip. Your fingers would pass through it like wading through a dream, brushing against something that is there and not there at the same time. Look outward along the horizon from this edge. The curve of the star drops sharply into the void, a boundary of extremes. The dense, crushing surface beneath seems to end abruptly, replaced by the dark emptiness of space, where only the faintest traces of light and gas linger. You could almost feel the weight of the atmosphere thinning, like standing on the edge of a cliff where the air becomes impossibly light, almost absent, yet the pull of gravity below still insists on holding you fast. And yet, in this near-nothing, something remarkable occurs. Light from distant stars bends sharply as it grazes the edge of the star, creating halos and distortions that dance and shimmer. You could reach your hand out and feel the faint pull of radiation, a tickle rather than a push, a reminder that even in the emptiness there is energy, a connection to the cosmos beyond this world. If you were to hover there, suspended at the interface of matter and void, your senses would be challenged in ways you cannot fully imagine. Sound would vanish entirely. The air is too thin to carry a whisper. Heat would feel inconsistent. The dense crust beneath radiates warmth in bursts, yet the thin edge above gives almost none. Your body, if it could survive, would register these contrasts sharply, muscles straining to adjust to the pressure below, while nothing presses against you from above. Notice too the magnetic field, as it stretches upward into this near-empty space. Twisted lines of force extend far beyond the crust, curving particles, bending light, shaping the view in ways no human eye has evolved to comprehend. You could see the faintest shimmer of ions spiraling along these invisible threads, a subtle glow that marks where the star's influence still reaches into the void. Time itself would feel different here. Each heartbeat seems prolonged, each motion deliberate, because the star's pull dominates even as the vacuum above whispers of freedom. You could step carefully toward the outer edge, sensing the subtle gradient from solid to nearly nothing, feeling the pull of gravity diminishing only slightly as you lift away, yet never fully escaping. And standing there, right at this edge, you might understand something profound. The neutron star is both a solid, crushing world and a bridge to the emptiness beyond. Its atmosphere, such as it is, merges almost seamlessly into nothing, creating a boundary that feels both extreme and delicate. You are caught in the balance, experiencing a place that is more than solid, more than empty, something that exists on the very edge of our understanding. Let us linger a moment at the edge of this neutron star, right where the dense crust ends and the almost non-existent atmosphere stretches upward into the void. The space around you is not empty in the way you are used to. It is alive with forces that twist reality itself. Could light from nearby stars even reach you? Or would it bend and twist unpredictably? This is a question that begins to unravel everything you thought you knew about seeing and being seen in the cosmos. In a normal place, light travels straight. It leaves a star, streaks across vast distances, and arrives at your eyes as a steady point or glimmer. You can trace it, measure it, even predict it. Here, standing at the neutron star's edge, that certainty vanishes. The gravity presses everywhere, curving space itself, bending the path of photons as they pass nearby. Rays from stars that should reach you in a line are pulled into arcs, swooping toward the surface, twisting around the curvature, sometimes even returning toward where they began. You might lift a hand to shield your eyes from the glare of a distant sun. Normally, the shadow would fall predictably across your arm. Here, it would behave strangely. Light could curve around the star, wrapping the glow of distant objects into your shadow, creating tiny streaks of illumination where none should be. Stars could appear doubled or smeared across the sky, their positions fluctuating depending on the subtle shifts in the magnetic and gravitational fields above the crust. Step back mentally and picture the sky around you. What once would have been a familiar constellation now bends in impossible ways. Lines of stars no longer trace the maps, you know. Some seem to loop back, forming tiny halos, while others are stretched thin into faint arcs across the darkness. You could watch a single star flicker as its light is alternately focused and deflected, as if the universe itself is playing with your perception. The surface beneath you adds another layer of complexity. Its density is so extreme that it warps space nearby, and the magnetic fields above twist the path of light even further. Rays from a star directly overhead may reach your eye from an unexpected angle, giving the impression that the sky is folding in on itself. The horizon is no longer a boundary. It becomes a gateway for distorted glimpses of objects that are both far away and strangely near at the same time. Even the faintest stars, those you would usually barely notice, behave unpredictably. Their light can scatter in arcs or refract along the magnetic lines that thread through the void above the star. Some may appear brighter than they should, their photons concentrated by the curvature of space, while others vanish entirely, bent around the star into regions where your eyes cannot follow. And yet there is beauty in this chaos. The unpredictability creates shimmering patterns across the sky, arcs of color where the field and gravity act together. You might see ribbons of starlight looping back on themselves, tiny halos of motion that mark the invisible currents in the vacuum above the crust. The faintest glimmer of a star might trace a line across the darkness like a spark caught in a spider's web, bending as if it has a mind of its own. Try to hold your gaze on one point. It will not stay still. The light is never quiet or constant here. Photons seem to dance, rushing along paths that change subtly with every magnetic flicker and gravitational tug. Your eyes strain to make sense of it, yet the brain can only follow so much. You are witnessing a sky that refuses to obey, a cosmos that bends the rules so that seeing becomes an act of surrender rather than observation. If you reached out, as much as your mind can, you would feel the faint tug of the photons themselves. Not heavy, not tangible, but enough to sense that their paths are not simple lines. Each beam carries the story of forces unseen, of curvature and twist, of energies that have traveled vast distances yet arrive here altered by the star's immense presence. Let us step back for a moment and take in the entirety of the cosmos from this impossible vantage point. You are standing on something so extreme, so densely packed, yet so small in comparison to the vast universe around it. How would the vastness of space look when you're on something so extreme and small at once? The sensation is dizzying, a collision of scale that stretches the mind and stretches the senses beyond anything familiar. Beneath your feet is a crust heavier than anything you could ever hope to lift. A solid sphere only about 20 kilometers across, containing more mass than our entire sun. And yet, just beyond the edge of your awareness, the universe unfolds in every direction. Stars, galaxies, and nebulae stretch endlessly outward, their light traveling across billions of kilometers to reach this tiny point. The contrast between the immense weight beneath you and the limitless emptiness above is staggering. It is like standing on the tip of a pin while the entire world spins in every direction around you. Look up and outward. The sky is no longer a dome or a ceiling. It is a panorama of motion, color, and light bending under the influence of gravity and magnetism. Stars twist into arcs, sometimes doubled, sometimes smeared into glowing lines, and distant galaxies appear in strange shapes, warped by the same forces that keep you pinned to the crust. You can trace the paths of photons as they curve in unpredictable ways, looping around the star or folding into faint halos. Space seems closer, yet farther away, intimate yet unreachable. The sense of scale is both terrifying and exhilarating. Tiny as the neutron star is, its gravity shapes everything immediately around it. Particles are caught in its grasp, light bends under its influence, magnetic storms stretch across the surface. Yet in the distance, the universe stretches on, billions of light years away, unshakable by even this extreme world. From here, you can feel the weight of the star beneath your feet, while simultaneously sensing the infinite freedom of space. Imagine how the horizon would appear. The star curves sharply, so that your feet and the far edge are both visible. You could trace the surface with your eyes in a single glance, seeing every ridge and crease. And yet beyond that horizon, stars shimmer and shift. Galaxies move slowly across the sky, and the black emptiness of interstellar space seems infinite. The contrast is like holding a grain of sand in your hand while gazing across an ocean of limitless water, knowing that the small object in your grasp has more weight than all that surrounds it, yet is almost nothing compared to the scale of everything else. And there is motion, subtle but constant. The neutron star spins, sometimes hundreds of times a second, turning the warped horizon into a rapidly shifting panorama. Magnetic flares erupt and race along the surface, sending arcs of colored light across the sky. The bending of photons creates patterns that dance, curve, and shimmer, reflecting the interplay of mass, magnetism, and distance. Space is alive with movement, yet the star beneath you feels impossibly stable, crushingly solid even as the cosmos around it seems to shimmer with life and possibility. Take a moment to consider the feeling of being both infinitely small and immensely heavy at once. Each step is loaded with gravity you cannot fully comprehend, yet your mind stretches out across billions of kilometers of dark emptiness, following the paths of light from distant suns. You are tiny and monumental simultaneously. Your presence seems insignificant against the scale of galaxies and nebulae, yet you are anchored to an object whose weight exceeds that of an entire star. Even the passage of time contributes to the sense of scale. Seconds feel slower here due to the gravitational pull of the neutron star, yet the universe beyond continues its steady rhythm. Stars flare and fade, cosmic dust drifts across unseen distances, and light travels vast expanses to reach your eyes. You witness motion both slowed and eternal at the same time. One heartbeat could stretch long enough for you to trace the path of a photon from a neighboring star, a simple particle carrying the story of the universe across unfathomable space. If you allow yourself to fully embrace it, you can sense the duality of your position. You are weightless in the context of the universe at large, almost insignificant in the infinite expanse of galaxies and dark matter, yet the crushing weight of the neutron star beneath you keeps you firmly anchored, tied to a reality so extreme it defies ordinary understanding. You are standing on a place that is at once microscopic in comparison to the cosmos and unimaginably powerful in its own right. Let us linger for a while in your mind's eye on this small but extreme stage, and now shift our gaze to the horizon of possibility itself. What would it be like to see a neutron star collide with another, shaking the cosmos around you? This is no gentle encounter. It is the meeting of two of the densest, most powerful objects in the universe, each packed with unimaginable mass, spinning and pulsing with energy that dwarfs anything we know. To witness it from the surface of one of them, even in thought, would be to feel the universe trembling in ways that ordinary senses cannot comprehend. Start by feeling the anticipation in the cosmos. These stars are drawn together by gravity over millions of years, spiraling closer and closer in a slow, inevitable dance. From your vantage point, the sky changes subtly first. Light from distant stars bends differently as the gravitational fields of the two stars begin to interact. Streams of charged particles ripple through space, tugging at the magnetic fields around you, causing faint glows to flicker across the neutron star's crust beneath your feet. You might feel a slight vibration traveling through the surface, a whisper of the approaching storm. Then comes the moment when the other neutron star looms in your sky. At first, it is tiny, a pinprick of dense energy far away. Yet, as it approaches, it grows quickly, the gravitational tug pulling not just on space itself, but on every particle on your own star. The crust beneath you, already unyielding, begins to hum with tension. Magnetic lines stretch and twist violently, and arcs of energy flare unpredictably, painting the sky in colors you cannot name. It is beautiful and terrifying, all at once. As the stars spiral closer, tidal forces stretch the crust beneath your feet. Imagine standing on a sheet of metal being pulled from both ends at once, but so extreme that even the tiniest movement threatens to fracture the surface. The gravity of the approaching star distorts the landscape, raising subtle ridges and depressions in the neutron star's crust. You feel each tremor in your bones, as if the star beneath you is alive, sensing the presence of its partner, preparing for the inevitable embrace. The sky itself becomes a swirling tapestry of energy. Light from the distant universe bends under the combined gravitational fields, creating arcs, halos, and smears of stars. Pulses of gamma radiation, normally invisible, would pass through space near you, interacting with the magnetic field and producing bursts of color across the surface. You could see ribbons of violet and green flare upward, twisting and fading, each one a signal of the immense forces at play. When the collision finally occurs, it is not an instant but a crescendo. Waves of gravitational energy ripple outward, shaking the crust beneath your feet, with pulses so powerful they would crush anything unprotected. Yet you are anchored to the neutron star, feeling each quiver, each surge of force, as a tactile measure of cosmic violence. The surrounding space itself quivers. Light bends unpredictably, stars distort and flicker, and the other neutron star merges in a brilliant display of energy, warping your perception of distance and time. You might catch glimpses of the resulting explosion of matter and energy. Some material is flung outward at immense speeds, forming clouds that shimmer as they interact with the magnetic field. Others are captured by gravity and spiral around the merged core, creating radiant rings that flash and twist in impossible patterns. The sky becomes a dynamic painting of motion and light, with new structures emerging where before there was only emptiness. And then there is the hum, the low vibration of space-time itself. The collision sends ripples outward that stretch and squeeze the universe. You do not hear them in the traditional sense, but you feel them as a resonance through the crust beneath your feet, through the very fabric of reality you are standing on. It is a reminder that this event is not just a visual spectacle, it is a disturbance of the cosmos, a heartbeat that echoes across billions of kilometers. As the merged neutron star settles into its new form, the sky begins to calm, though the memory of the collision lingers. Streams of light continue to bend and shimmer, magnetic fields slowly untwist, and the crust beneath you trembles less intensely. Yet the experience leaves an imprint on your perception. You have seen the raw, unfiltered power of the densest objects in the universe meeting in a violent embrace, and the cosmos itself has responded, shifting and bending around you in ways that are impossible to capture anywhere else. Let us lift ourselves slightly in thought, hovering just above the neutron star's surface, suspended in a place that seems impossibly small and impossibly heavy at the same time. Could you imagine floating just above the surface, feeling the pull of billions of tons in a single step? It is not a gentle tug like the gravity we know on Earth. It is an almost overwhelming force, a weight that presses on every molecule of your body, yet at the same time, you are suspended, hovering in a fragile balance between falling and floating. Picture raising a foot and letting it hover for a heartbeat. Even the tiniest movement feels monumental. Each step toward the surface is a negotiation with forces you cannot see, a careful push against gravity so immense it would crush ordinary matter instantly. Beneath you, the crust waits like a solid ocean, unyielding, yet vibrating slightly with energy, trapped from the star's magnetic storms and internal pressures. You can feel those tremors through the tips of your toes, small but insistent reminders of the scale of the world you hover above. If you were to lift both feet and float slightly higher, the pull intensifies, reaching into your core as though every atom in your body is being stretched toward the star. The sensation is not just physical, it is mental as well. Your mind strains to comprehend the contrast between your fragile existence and the immense weight of the surface just beneath you. It is almost impossible to conceive of standing here and being whole, to exist in this place without being torn apart. And yet, the experience is strangely beautiful. The airless space around you, almost nothing, stretches endlessly. Stars twist and bend above, their light distorted by the gravitational field of the neutron star. Rays of distant suns smear across your vision in arcs, some doubling back on themselves, some stretching into long ribbons of color. The ground beneath you seems both impossibly near and impossibly distant, a paradox that defies ordinary perception. Imagine reaching a hand downward, fingers almost brushing the crust. You feel the pull stronger through your fingertips, the sensation of billions of tons pressing invisibly, yet unmistakably on every square centimeter. If you could see it, the gravitational field lines would fan out around you like invisible strings, pulling light and energy into patterns you could almost trace with your eyes. Every ripple in the star's crust, every flare of magnetic energy, sends a subtle pulse through these lines, brushing your skin and vibrating against your bones. Hovering here also changes your sense of time. Every second feels slower, stretched by the immense gravity of the star. Movements that normally take a fraction of a second on Earth now feel prolonged. You might lift a finger and sense the infinitesimal delay as the pull of the star holds back your motion. The world around you seems both frozen and alive, a paradox of extreme density and extreme emptiness, of immense weight and delicate suspension. As you shift slightly to balance yourself above the surface, you become aware of the magnetic storms above the crust. Charged particles spiral past your position, some brushing near, some racing in arcs that flare and fade. Their energy interacts with the field lines and the surface, creating shimmering ribbons of color beneath your hovering feet. It is a reminder that even in this suspended moment, the neutron star is alive, dynamic, and unceasing in its forces. Floating in this state, you become acutely aware of scale in ways impossible elsewhere. You are almost infinitesimal compared to the star's mass, yet every step, every small motion, is dominated by forces that could crush continents on Earth. The contrast between your delicate body and the unfathomable power just below is a lesson in the extremes of existence, a visceral awareness of the limits of life as we know it. Let us pause again above the neutron star, letting the mind settle into the unusual rhythm of this place, and think carefully about time itself. How different would time feel if you compared seconds there to seconds on Earth? The experience is not just subtle, it is profound, altering perception, motion, and even thought in ways that stretch the imagination. Imagine standing on the surface, or hovering just above it, as we have been doing. On Earth, a second is uniform, predictable. Your heartbeat, the swing of a pendulum, the fall of a raindrop, all obey a rhythm we take for granted. Here, under the crushing gravity of the neutron star, that same second is stretched. One pulse of your heart might feel like 2 or 3 or more. Movements you perform take longer to complete, not because you move slower, but because time itself is unfolding more gradually in your local frame. The difference is subtle at first, like walking into a thick fog, but the effect grows as the gravitational field increases near the surface. Your thoughts themselves begin to feel drawn out. Ideas that normally flicker through your mind arrive in elongated sequences, each one given more space to develop and more time to be considered. Simple acts like lifting your hand or turning your gaze become deliberate, measured gestures, each one a negotiation with the slowed passage of time. You feel as if you are observing yourself from a slightly removed perspective, aware of every micro moment as it stretches out before you. Now, picture looking outward toward the distant stars. Light that would normally appear to twinkle in regular intervals now seems slightly out of sync. Pulsars, spinning rapidly, send flashes that appear longer, stretched by the strong gravitational field nearby. A star flare that would normally last milliseconds seems to linger, giving you time to notice details, to watch the subtle interplay of color and energy that would be invisible elsewhere. Time has become a magnifying lens for cosmic events, and the universe is revealing secrets that your earthbound perspective could never detect. As you take in the horizon, bending under your feet and curving with the star's mass, you sense that even motion across the surface is affected. Walking a single meter would feel elongated, every microstep drawn out in slow motion relative to someone far away, floating in the emptiness beyond the star's gravity. Your muscles might strain against forces impossible to replicate on Earth, yet time itself is granting you the sensation of more space, more opportunity to perceive each infinitesimal movement. Even the falling of particles near the surface illustrates the effect. A bit of dust or a microscopic fragment of matter might tumble downward, yet to you, it seems almost suspended, taking its time to reach the crust. The immense gravitational pull accelerates it, but the warping of time stretches the event in your perception, creating a tension between speed and duration. You see the interplay of forces in slow motion, a visual and sensory ballet that would be incomprehensible in a weaker field. And think about communication with the outside universe. If someone on Earth were observing you, their seconds would pass faster compared to yours. They would see you moving in slow motion, gesturing in drawn-out arcs, while you perceive them as rushing past in a blur. The difference is not merely perception, it is an alteration of experience itself. Each second on the neutron star carries the weight of countless seconds elsewhere, and each heartbeat you feel is imbued with the gravity of being in this extreme environment. You might even sense the effect in your own memories. Moments linger longer in your mind, each thought and sensation held in exquisite detail. A glance at the distant stars, a flare of light, or a ripple across the crust beneath your feet stretches into an extended, almost cinematic experience. Time is no longer linear or uniform. It is a tangible, malleable medium that wraps around your senses, bending reality in subtle but profound ways. Let us turn our attention now to one of the most dramatic forces you could ever experience while standing near or above a neutron star: the magnetic storms. Could you survive the magnetic storms, or would they tear reality itself apart around you? It is not an exaggeration to say that these storms are unlike anything found anywhere on Earth. Their strength is beyond human comprehension, trillions of times stronger than the strongest magnetic fields we know, and they dominate every particle, every photon, and every movement of energy above the star. Picture the sky above the neutron star. Normally dark, it begins to shimmer as magnetic lines twist and coil, like invisible threads being pulled taut by unseen hands. Particles caught in these lines spiral at nearly the speed of light, releasing bursts of energy as they collide and bend. If you could see them, they would appear as ribbons and arcs of glowing plasma, moving in patterns that defy expectation, flashing in colors that do not exist in ordinary perception. The airless space above vibrates with the sheer intensity of motion, yet the vibrations are not sound waves as we know them. They are pulses of energy, trembling through space and through the star's crust alike. Hovering or standing on the surface during such a storm would feel impossible to the body you know. The crust beneath you might hold firm, yet the airless space above is filled with invisible forces pulling, twisting, and pushing. The star's magnetic field could accelerate particles into arcs that flash along the horizon or across your line of sight. Reaching out would not be a gentle touch. It would be a brush with currents that could rearrange matter at a subatomic level, bending the behavior of atoms themselves. Your senses would be overwhelmed, even if somehow your body could survive the gravity. Light itself would shimmer and refract unpredictably as photons interact with the twisting field. You might see halos of energy flare and collapse, streams of charged particles dancing and looping like threads of fire, and ribbons of color that twist and shimmer across the entire sky. Stars beyond the star's immediate vicinity might flicker or shift in impossible arcs, creating patterns that look almost alive, as though the cosmos itself is trembling. Time, too, would feel distorted. As the magnetic storm pulses through space and interacts with the star, the stretching of seconds caused by gravity combines with the rapid, violent oscillations of energy. Moments feel both prolonged and instantaneous. A single flare of radiation could streak across the sky in microseconds to a distant observer, yet to you, it might linger long enough for your eye to follow its path, to trace every curve and shimmer along the way. Imagine the pull on your very thoughts and sensations. Magnetic fields at this strength do more than bend light or influence particles. They would interact with any electrically conductive material, your instruments, and potentially, even with neural activity, if protection were not perfect. The idea of surviving is less a question of physical resilience and more a question of being able to exist at all without the very forces around you overwhelming your senses. Your mind would be pushed to the limits of perception, feeling patterns of energy that your body is not built to comprehend. Yet in the midst of this chaos, there is beauty. The magnetic storms create a cosmic light show that no other place in the universe could replicate. The arcs of energy flare in brilliant colors, looping and twisting with a fluidity that contrasts sharply with the unyielding solidity of the crust beneath you. Particles streak along invisible lines, creating glowing threads that connect distant points of the star's surface in patterns that seem deliberate, almost like an artist painting with energy and light. If somehow you could survive the experience, the memory of it would remain with you forever. The combination of extreme gravity, the density of the crust, and the unrelenting magnetic force would imprint a sensation unlike any other. You would know what it is to feel the universe bend around you, to sense the interaction of unimaginable forces all at once, to perceive the raw power of a neutron star's magnetic energy as a presence in the very space you occupy. Let us return our attention to the surface of the neutron star, to the crust beneath your feet that is both impossibly solid and unimaginably energetic. Could you sense the immense energy trapped beneath your feet, enough to power entire galaxies? It is difficult even to describe, because what you are standing on is not just matter as we know it. Every cubic centimeter is loaded with mass so dense that a teaspoon would outweigh a mountain. That density stores energy in ways that seem almost magical, almost alive. And if your mind could stretch far enough, you might feel it vibrating beneath you like a silent, endless pulse. Imagine placing your hand lightly on the surface. It would not be heat as you know it, not warmth radiating gently from a fire, but a kind of latent energy that hums beneath the crust, pressing against you through the rigid lattice of the star. Each atom is packed so tightly that its internal energy is immense, and the sum of trillions upon trillions of atoms creates a reservoir of power so vast that it boggles the imagination. You are standing atop a force that could, if harnessed, fuel stars and galaxies for billions of years. Look out across the horizon. The neutron star is tiny by cosmic standards, only 20 kilometers across. Yet the energy contained within it is concentrated into a volume so small that its gravity is crushing. Its magnetic fields are staggering, and its latent energy radiates subtly, twisting the space around it. You might feel it as a faint pull, a low vibration traveling up through your legs and into your chest, a pulse that resonates in time with the invisible heartbeat of the star. Reach down and imagine pressing a fingertip against the crust. Even that small act connects you to forces beyond comprehension. Energy stored in the density of matter, in the spinning neutrons tightly packed together, wants to escape, to radiate, yet it is confined by gravity and structure. That tension is palpable, a subtle pressure that whispers through the star's lattice, through every ridge and fissure. It is not threatening in a conventional sense, but the awareness of it fills you with awe, as if the universe is pressing its secrets into your mind through the soles of your feet. And there is motion in this energy. Magnetic fields twist and coil above the crust, flaring occasionally in bursts of radiation. The crust itself vibrates subtly, carrying energy from deep within to the surface, a constant hum of matter in impossible compression. You might imagine standing still for hours and feeling every fluctuation, every wave of energy as it travels outward, a silent symphony that carries the raw power of creation. The scale of it is staggering. A single gram of matter from this star contains more energy than all the bombs ever detonated on Earth. Multiply that by the mass of the star, and you begin to approach something almost inconceivable. Billions of tons of energy press down and swirl beneath your feet, and yet you are alive, aware, suspended in a moment where comprehension and perception stretch thin across this extreme reality. Even light that grazes the surface interacts with this energy, bending slightly, scattering in patterns influenced by magnetic fields and the weight of the dense matter. You could see faint halos of distorted light tracing the edges of ridges, highlighting the presence of power that cannot be measured by ordinary means. Every pulse of radiation, every magnetic flare, every microscopic vibration in the crust reminds you that you are in contact with something more than solid matter. You are touching the concentrated essence of energy, a force that could ignite stars and sustain galaxies. If you allowed your senses to expand into awareness, you might almost feel the energy trying to move, flowing through invisible channels, seeking pathways into the void. It is trapped, yes, but not inert. There is a tension, a silent hum, a sense that creation itself is stored here, compressed into the star's tiny frame. You feel connected to it simply by standing, your body a witness to the extremes of physics, to a scale of power that dwarfs anything in human history or imagination. Let us take a deep breath and center ourselves above the neutron star, allowing your mind to stretch as we consider the distortions of scale and perception in this extreme environment. How would your perspective of size and distance warp under the star's gravity? The answer is not simple, because the rules of ordinary perception bend alongside space itself. The immense gravity beneath your feet, the curvature of the star, and the intense magnetic fields all combine to create a reality in which distance and size no longer follow the patterns you are used to. Look down at the crust beneath you. In a normal place, A ridge or fissure would appear only as it is, its size measurable with a glance or a step. Here, the intense gravity compresses your perception. Objects that are actually small can seem enormous, stretched along the curve of space, while larger structures may appear compressed or flattened, their true magnitude hidden by the distortion of space-time. Every contour, every ridge, every small particle of matter is warped in a way that makes you feel both minuscule and monumental at once. Now lift your eyes toward the horizon. The curvature of the star is sharp, falling away quickly under the immense gravitational pull. What would normally be a gentle slope across a planetary surface now appears steep, almost cliff-like. Distances that seem short to your eyes are actually vast in terms of the path light must travel. The horizon feels close enough to touch, yet it is impossibly distant in reality, a paradox created by the stretching and bending of space itself. And when you look outward into the cosmos beyond, the distortions grow even more surreal. Light from distant stars bends unpredictably as it passes near the star, creating arcs, loops, and halos that make objects appear shifted or multiplied. A single star might appear to hover in several places at once, its image smeared across the sky, while a cluster of stars could stretch into a long, glowing ribbon. Your sense of how far away objects are becomes unreliable, as gravitational lensing twists and magnifies sections of space. You might reach out with your mind and try to trace the path of a photon from a distant star. The straight line you expect is gone. It curves around the star, loops briefly, and bends again, perhaps doubling back toward your eye. Distances that seem measurable are deceptive. What you perceive as nearby could actually be many kilometers away along the curved space-time. The vastness of space compresses and expands, depending on the paths light takes, and your mind struggles to map the reality of size and distance against the sensory impressions before you. Even objects on the star itself are deceptive. Magnetic flares arc across the surface, following invisible lines of force, and the curvature of the star exaggerates or diminishes their apparent length. Cracks and ridges in the crust may appear closer or farther than they actually are, and the pull of gravity exaggerates motion as you observe it. A particle moving across the surface may seem to glide effortlessly along a smooth curve, when in reality, it is moving against tremendous forces. Try to imagine walking a few meters along the crust. Each step stretches out visually, the landscape bending around you. Rocks and ridges that would normally seem solid and finite appear to shift as your perspective is altered by gravity. The star beneath you seems both enormous and tiny at once, a paradox that stretches your mind in multiple directions. You can feel the pull of the mass beneath every step, yet your eyes struggle to reconcile the true scale of what you see. Look outward at the sky once more. Even galaxies and stars at immense distances appear warped. Some are magnified, distorted into arcs or smears, while others seem compressed, their light twisted along gravitational pathways that your eyes cannot fully follow. Distances that should seem constant fluctuate as your perception adjusts to the curvature of space-time. The universe feels closer and farther at once, intimate yet infinite, compressing billions of light-years into a visual tapestry that your mind can almost comprehend but never fully measure. The combined effect of gravity, curvature, and magnetic influence makes standing on a neutron star unlike observing anything else. Your mind and senses are caught between extremes: the crushing density of the crust beneath you, the violent energy spiraling above, and the distorted universe stretching outward into impossible distances. Every glance, every movement, every observation is filtered through the star's influence, warping your sense of reality, scale, and distance into something profoundly alien yet mesmerizing. Let us focus now on the crust beneath your feet, that impossibly dense surface, and consider a question both simple and extraordinary. Could you leave footprints there, or would gravity erase them instantly? The answer is more complicated than it seems, because the physics of a neutron star are beyond ordinary comprehension, blending the extremes of density, gravity, and magnetic force in ways that bend intuition. Picture lowering a foot toward the crust. The surface itself is solid, yet it is a material far different from rock or soil on Earth. Each centimeter is packed with the weight of mountains and the energy of entire stars. The crust resists penetration with an intensity you cannot imagine. If you attempted to press your foot down, even gently, the atoms beneath would push back with a force that could fracture bones instantly on Earth. In a sense, leaving a footprint is not about crushing the material. It is about surviving the sheer presence of the mass under your weight. Even if somehow your body could endure the gravitational pull, the effect of gravity would erase almost anything resembling a mark almost immediately. The crust is under immense pressure, and any slight indentation would be smoothed as the solid matter redistributes itself at the subatomic level. The concept of a footprint here is not one of visible depression, like sand or mud. It is an ephemeral trace, a momentary disturbance in a medium so extreme that it resists change and seeks equilibrium instantly. Now imagine hovering just above the surface, toes barely brushing the star's crust. Each step presses you down with the force of billions of tons. Even the smallest movement sends ripples through the atomic lattice beneath your feet, a subtle vibration that travels across the crust. These ripples are transient. They spread and vanish in milliseconds, leaving no lasting impression. You can sense the energy released by the interaction, feel it reverberate through your body, but the surface itself remains unmarked, unyielding, immutable. Consider the scale of the effect. On Earth, footprints are visible because soil, sand or snow can compress and retain an imprint. Here, the forces are so intense that matter behaves almost like a fluid at the atomic level, even while appearing solid. Any depression or trace left by your foot would be quickly leveled by the crust's own internal pressure, a silent but absolute correction to maintain stability. The surface resists change not out of choice but because of the extreme physics governing its atoms. Even light itself, interacting with the surface, behaves strangely. If your footprint were somehow visible, the bending of light under the star's gravity would distort its appearance, stretching or compressing it unpredictably. The horizon curves sharply, and the magnetic fields above the surface twist photons in ways that make fixed shapes nearly impossible to perceive. Any trace of motion, any mark, would be ephemeral not just physically but visually, an illusion quickly erased by forces beyond ordinary experience. And yet, there is a subtle beauty in the act of leaving a footprint, even if it is transient. The moment your foot presses downward, a vibration travels through the lattice of matter, a pulse that carries the story of your presence across the star's surface. Though it will vanish almost instantly, you can sense it, almost like a whisper in the fabric of reality, a fleeting connection between your fragile body and the immense, extreme star beneath you. Hovering slightly higher, you might feel the aftermath of this ephemeral contact. The atoms beneath continue their subtle vibrations. Magnetic fields interact with charged particles nearby, and light curves unpredictably across the crust. Your presence has disturbed the equilibrium in an imperceptible way, leaving behind energy, motion, and ripple patterns that exist for only the briefest instant before the surface reasserts its immutable nature. Standing here, you realize that leaving a footprint on a neutron star is less about making a mark, and more about sensing your presence in the interplay of forces. The surface beneath you is alive with tension, energy, and motion, responding to every touch with invisible precision. Even if the crust erases every trace, you feel the connection, the dialogue between your body and the extreme matter, a silent acknowledgement of your temporary existence in this impossible environment. Let us turn our attention now to the invisible but undeniable force that envelopes the neutron star, the magnetic field that stretches and twists across space. What would it feel like to touch the edge of a neutron star's magnetic field, stretching reality itself? This is no ordinary sensation. You are reaching not for matter or light, but for the very framework of energy that shapes the star and bends space around it. Picture extending your hand into the field, hovering just above the crust. At first, it might seem like nothing is there. Airless space is empty to the senses, yet as your fingers enter the edge of the magnetic field, you begin to sense a subtle pull, a tug not just on your body, but on space itself. Every particle around you feels it. The field interacts with charged particles, bending their paths into long, spiraling arcs. If your hand could sense these invisible threads, you would feel them vibrating with immense energy, like strands of a cosmic harp being plucked by an unseen hand. As you move deeper into the field, the pull grows stronger, almost overwhelming. The magnetic force twists the paths of ions and electrons nearby, creating currents of energy that pulse along invisible lines. Your fingertips would sense something unlike weight or pressure, more like a force woven into the fabric of reality. It is not pain or resistance, but a sense of being inside a tension that holds the star together and governs every particle within miles of its surface. You feel reality bending under the influence of a power so extreme that ordinary matter behaves differently in its presence. Now imagine light itself reacting to the field. Photons that pass near your hand bend slightly, twisting along the lines of energy. The sky above you shimmers with distortion. Stars that are normally points of light stretch into arcs, loops, and halos, some appearing to move along the lines of force. It is as if the universe itself has become a fluid, malleable, and alive, and your hand has entered the currents that sculpt its flow. Colors shimmer in ways you cannot name, blending into ribbons that ripple across the void above the neutron star. And the sensation is not static. The magnetic field pulses and twists with the spin of the star, flaring and coiling with bursts of charged particles. These surges create waves of energy that travel outward, brushing past your hand and resonating through the crust beneath your feet. You can feel the low hum of motion, the vibration of energy moving through space itself, like the universe breathing at a scale you cannot normally perceive. Every instant is alive, a mixture of power, movement, and light that interacts with everything in its reach. Consider the paradox of scale. The field extends for thousands of kilometers, and yet you are reaching only the outer edge. Even there, its power is enough to bend atoms, twist light, and reshape the paths of particles. You feel the connection between the micro and the cosmic, the tiniest motion of your fingers resonating with forces that could influence matter miles away. The boundary of the field is a liminal space, neither fully tangible nor fully abstract, a place where physics, as you know it, stretches and flexes. Hovering in this zone, you might sense time itself warping. Seconds seem to stretch and compress as energy flows along the magnetic lines. Movement feels delayed yet immediate, a duality created by the extreme interaction of gravity and magnetism. You might lift your hand and watch it trace an arc of light along the field, a path that seems to shimmer and shift as the energy pulses. Every motion, every gesture, is amplified and distorted, as if reality itself responds to your presence. And yet, there is beauty in the force. The magnetic field is like a living sculpture, twisting and shaping light, energy, and matter around it. You can almost see the invisible strands of power forming patterns, spirals, and arcs that ripple outward. It is a reminder that even in the extremes of physics, there is elegance, a natural artistry created by forces that operate far beyond human comprehension. Let us linger for a moment above the neutron star, letting your mind stretch as we consider the invisible yet unrelenting forces at play. Could you survive the tidal forces trying to pull you apart in every direction at once? It is difficult to even imagine because these forces are unlike anything experienced on Earth. Here, gravity does not simply pull downward, it acts in all directions at once, tugging at every part of your body, every particle of matter, with unequal strength, and the result is an intensity that warps both space and perception. Picture standing or hovering above the crust. The neutron star is small in size, only about 20 kilometers across, but its mass is colossal. A single step toward the edge could result in a difference of billions of tons of gravitational pull between your head and your feet. Your body would be stretched like a rubber band, compressed along one axis and pulled along another. Every organ, every molecule, would feel the tug of forces so extreme that the concept of survival seems impossible. Ordinary bones, muscles, and even atoms would struggle to maintain cohesion under this invisible siege. Now imagine reaching a hand outward toward the horizon. The difference in gravitational pull between your fingers and your torso is staggering. The tiny variance in distance from the star's center translates into a colossal difference in force. Your fingertips would be tugged relentlessly, your arms stretched as if reality itself were trying to extend you into space. Even your vision would be affected because light itself bends under these extreme gradients, warping the appearance of the surface, the sky, and the stars beyond. The tidal forces are not constant in a simple way. As the neutron star spins, as magnetic storms flare, and as the crust vibrates subtly, The pull changes minutely but relentlessly. You would feel a rhythmic stretching and squeezing, a pulse that travels through your body and resonates in your very bones. Each micro-movement becomes a negotiation with gravity itself, a delicate effort to resist being torn apart while sensing every subtle pull and tug around you. Consider the surface beneath your feet. Even the solid crust of the star cannot fully shield you from these forces. The difference in gravity from 1 centimeter to the next is enormous. Step slightly forward or sideways and the pull changes perceptibly. The crust itself might flex or ripple under the combined effect of the internal pressure and your body's mass, though it remains overwhelmingly solid. You sense the tension between the unyielding matter beneath you and the relentless pull attempting to elongate and compress everything in contact with it, and the sensation is magnified by awareness. You are conscious of every atom, every molecule, every connection in your body being tugged in ways that defy ordinary experience. Movements that are simple on Earth, like raising an arm or leaning forward, become a negotiation of impossible forces. Even blinking could create a tiny distortion in your alignment relative to the crust, exposing you to differences in gravitational pull along fractions of a meter. The awareness itself is dizzying, an assault on mind as well as body. Hovering slightly above the surface, the effect extends outward. Your body is a bridge between 2 points, each feeling a different pull from the star's center. Particles near you are stretched along magnetic field lines or deflected by minor curvature in space. The very notion of remaining whole feels almost miraculous, an improbable feat of presence amid forces that seem determined to disassemble you. You are acutely aware of the immense energy required simply to maintain cohesion, even without moving. Yet there is a strange elegance in the tidal forces. They are not chaotic. They are predictable in the sense that the laws of physics govern them with perfect consistency. Every pull, every stretch follows the star's mass, its density, its curvature, and its spin. If you could perceive it fully, you would see a pattern, a structure in the forces that mirrors the order of the star itself. Awareness of this structure gives a sense of beauty, even amid the terror of the sensation. If somehow survival were possible, it would require more than strength. It would require an understanding of the star's geometry, of how forces change from point to point, and a capacity to interact with them in ways that preserve cohesion. Even imagining this possibility is to recognize the extremes of the universe, to feel how fragile life as we know it would be in the presence of such intensity, and to marvel at the scale and precision of forces that shape the cosmos in ways we can barely perceive. Let us drift toward the final thought in this journey, the moment when you imagine leaving the neutron star behind, and in the end, what would it feel like to step off, returning to the familiar pull of Earth, forever changed? The transition itself would be profound, not just physically but mentally, emotionally, and even spiritually. You have been suspended in a place of extremes, surrounded by forces so vast and alien that every instinct, every sense, every perception of reality has been reshaped. To leave is not merely to walk away. It is to move from one universe of sensation into another, a dramatic shift that you can feel in every fiber of your being. Picture stepping backward, rising from the crust or hovering slightly above it, and allowing the neutron star's grip to release its hold gradually. The gravity that once pressed down with the weight of mountains and billions of tons begins to lessen. Your body, stretched and strained by the immense tidal forces, feels relief in a way it has never known. Bones, muscles, and atoms return to a scale where ordinary strength suffices. Even breathing, which was once a thought experiment under crushing weight, now flows naturally and easily. You notice the subtle pulse of Earth's gravity as a gentle, familiar tug, almost soothing after the extremes you have endured. Yet the mind is not so easily reconciled. Time, perception, and scale have been stretched and twisted during your stay. Seconds on the neutron star passed in ways that felt prolonged, movements that seemed slow yet precise, energies that whispered in a cadence you had never imagined. Returning to Earth, you sense the difference immediately. Ordinary moments feel compressed, everyday movement quick and almost too light. You might blink and feel as though the universe has accelerated around you, yet your mind remembers the stretch and pull of neutron star time, lingering as an echo in your awareness. Look around at the familiar horizon. Mountains, Trees, rivers, and skies appear simple, almost quaint, after the extreme curvature and distortion of space near the star. Distances are measurable in a straightforward way. Gravity is gentle, and air offers resistance and support in a manner you had forgotten. Colors and light behave predictably, no longer twisted by magnetic fields trillions of times stronger than Earth's. There is comfort in this predictability, yet the memory of the neutron star lingers, a sense that nothing in ordinary experience could ever truly prepare you for the vast and alien forces you have witnessed. The body itself carries the imprint of the experience. Tiny muscles and nerves may remember the sensation of being stretched and compressed by tidal forces. Your bones might feel lighter, your movements more fluid in contrast to the crushing pull you endured. Breathing, walking, turning your head, even closing your eyes, all feel different, heightened by comparison to what you just left behind. The familiar pull of Earth feels almost delicate, a reminder of how fragile yet resilient ordinary matter is compared to the extremes of neutron star physics. Emotionally, there is a mixture of awe, relief, and humility. You have touched forces that shape the cosmos, felt energy that could power galaxies, and sensed matter in its most extreme state. That experience cannot be forgotten. There is a quiet reverence, a deep appreciation for the balance and scale of life on Earth. The extremes you left behind are no longer threatening, but their memory lingers as a constant reminder of the universe's power and your own small yet conscious presence within it. Even the mind's perception of time carries a residue. Seconds on Earth feel fast now, yet the echo of stretched moments and prolonged perception remains. Memories of light bending, magnetic storms twisting across impossible distances, and tidal forces tugging at your body create a surreal contrast with everyday life. You carry with you an awareness of the universe's extremes, an understanding that reality can stretch, twist, and overwhelm in ways that ordinary experience cannot prepare you for. And perhaps most profoundly, stepping off the neutron star changes your sense of possibility. You realize that the universe contains realms utterly alien, forces that defy intuition, and beauty that exists in extremes beyond imagination. You see the Earth with fresh eyes, understanding both its fragility and its stability, feeling gratitude for the simple pull of gravity, the gentle passage of time, and the predictability of light and matter. The memory of the neutron star transforms your perspective, not as a single moment, but as a lasting expansion of what you consider possible. As your feet touch familiar ground, you feel a mixture of relief, wonder, and transformation. The star itself lingers in your awareness, a silent teacher of extremes, a reminder of the unimaginable density, gravity, magnetism, and energy you once touched. You realize that life, movement, perception, and reality are all relative, shaped by forces both subtle and colossal. Returning to Earth, you are whole yet changed, carrying with you the imprint of a place where the cosmos reveals its most extreme truths, a place where the ordinary rules of sensation, movement, and perception are rewritten, if only for a brief, unforgettable moment. Let us linger a while in this final reflection, letting your mind and senses settle after all that you have experienced above, on, and around the neutron star. Imagine standing fully on Earth again, the familiar pull of gravity grounding you, the air flowing freely, the sky wide and open above. Your body breathes easily, your muscles and bones no longer strained or stretched by impossible forces. Yet your mind carries the echoes of what you have witnessed, a memory of extremes so vast and alien that ordinary experience can never erase them. Think of how the crust beneath your feet once held the weight of billions of tons per square centimeter, how each step on that tiny sphere of concentrated matter would have pressed against every fiber of your being. You recall the tidal forces tugging at you from every direction, the subtle stretching and squeezing that reminded you of your own fragility, and the hum of energy trapped beneath the surface, enough to power galaxies for eons. Even now, in the calm of Earth, your body remembers the sensation of that extreme density, a quiet pulse of awe and reverence vibrating through your memory. The magnetic fields, twisting and writhing in invisible currents, created a spectacle and sensation unlike anything else in the universe. You reached into them, sensing threads of energy that shaped light, matter, and space itself. The flares and distortions, the ribbons of color that shimmered across the star's atmosphere, remain vivid in your mind. They are no longer physical sensations, yet their memory is almost tangible, a lingering hum of power that stretches the imagination. Every glance at the night sky reminds you of those invisible lines and pulses, making familiar stars seem both close and impossibly distant. And then, there is the perception of time, stretched and warped by gravity so extreme that seconds elongated and movements slowed, giving you the sensation of existence in a slowed, almost cinematic frame. You now perceive time differently, appreciating the subtle variations and textures of each passing moment, aware that reality itself can bend and twist, that seconds are not always uniform, and that the cosmos has rhythms both subtle and overwhelming that you could never fully experience on Earth. Your sense of scale is forever altered. Objects that once seemed vast now appear small when compared to the condensed mass of the neutron star. Distances between stars, galaxies, and even light years themselves feel both intimate and impossible, as if the universe stretches and contracts depending on perspective. The universe has become a living tapestry of extremes in your mind, a place where you can almost sense the pull of forces too immense to measure, where light bends in ways that defy ordinary perception, and where every action is both delicate and monumental. Emotionally, the experience leaves a profound imprint. Awe and humility mix with exhilaration and reverence. You realize that human perception is fragile, that life is delicately balanced on a scale so small compared to the forces of the cosmos, yet somehow capable of observing, understanding, and marveling. There is gratitude for the ordinary, for the gentle pull of Earth's gravity, for the predictable flow of time, and for the comforting stability of the familiar. Even as your imagination stretches across extremes it has glimpsed, even ordinary acts walking across a field, touching a tree, gazing at a sunset take on new weight and meaning. Each step, each breath, each glance reminds you of the extremes you touched, the density, energy, and magnetic forces that dwarf anything in ordinary experience. The universe feels richer, more intricate, more alive with hidden patterns and forces than you could ever have imagined before your journey. And there is a quiet, lingering wonder that nothing can erase. You have stood where few could even imagine, reaching into forces that define the limits of matter and energy. You have felt the tug of gravity so intense it could stretch your body, the pull of tidal forces from every direction, the hum of energy beneath the star, and the twisting, luminous currents of a magnetic field beyond comprehension. All of this leaves a resonance within you, a connection to the cosmos that is personal, immediate, and unshakable. Returning to the ordinary world, you carry this resonance as a lens through which all future experiences of space and matter will be filtered. Stars twinkle with new meaning, galaxies seem to pulse with hidden energy, and even the quiet night sky holds echoes of forces too immense to measure. You understand, more deeply than before, the interplay of gravity, energy, and time, and the fragile balance that allows life, observation, and consciousness to exist in a universe that is at once harsh and astonishingly beautiful. The final sensation is one of profound transformation. You are grounded, yes, but stretched mentally across scales and forces that the earthbound mind rarely contemplates. You carry the memory of extremes, the hum of energy, the pull of tides, the warping of time, and the shimmer of magnetic currents. You are forever changed, a witness to a world that few could even imagine, and a participant in a moment where physics, perception, and imagination intersect. As you settle fully into the familiar pull of Earth, take a moment to feel the lingering echo of the neutron star. Sense the vast energy you once hovered above, the density that defies comprehension, the magnetic fields twisting light and matter around you, and the tidal forces that stretched your very being. Let gratitude and awe fill you, and allow the memory of this extraordinary journey to deepen your understanding of the universe, of existence, and of the delicate, astonishing balance that allows life and consciousness to observe the cosmos at all. You now carry within you a sense of extremes made tangible, an awareness of forces beyond imagination, and a quiet reverence for the delicate order of the universe. The neutron star, in all its impossible density, gravity, and energy, has left its imprint on you forever. You are returned to familiar ground, yet nothing will feel ordinary again. Every glance at the stars, every thought about distance and scale, every sense of time and energy will be colored by the memory of standing at the edge of matter itself, experiencing the unimaginable and returning alive, aware, and profoundly transformed.